Hi folks, I'm Chuck Black. We're doing the quokka walkthrough. We are on walkthrough number 16, and in this lesson we are going to be talking about the background threads that run that give us all of this cool information that you see in the quokka graphs and tables and things of that nature. In the lesson we're going to be looking in more detail at how the threads get started up, as you see right here. We'll also talk about how they get shut down. We will look at particular threads and look at how they get started and the different ways that we create tasks, and then we create a thread from that task and point it at the actual function that we want it to run, and how we actually initiate it within the thread. We'll look at where it actually gets called when it started, how we loop through it and continue to do that forever until it's time to terminate. So that is what we're going to do. We will be looking at, in more detail, the services thread, simply because it's pretty simple and all the others do effectively the same thing. In other words, the pattern of how it's implemented is the same. Hopefully it will be a useful few minutes for you to spend learning about how quokka works and the quokka internals of starting a thread and running a thread. So without further ado, let's get started. Okay, so today's topic on our quokka walkthrough is going to be all of the background processes that are running to do stuff in quokka. Now, I use the word processes in a generic sense. Technically, they are actually threads that are running in quokka. So what are we talking about? Well, when you looked at a list of hosts or devices or services and you see things like the status change from green to red or red to green, or you look at response time and how that changes periodically, or last heard, how it sometimes is the currently up to date, like this value right here. It's 1054, as you can see, so that's pretty much up to date. This one hasn't been heard from since 8:25, and that's probably because that's the point in time where I believe my wife left and took her phone or whatever to work, and so that is no longer available to be pinged. So there's that type of information. If we drill down, then we can see graphs of this information that keep getting updated, whether it's response time or availability. Or what about this stuff that gives hourly values, the summarization graphs? There's that type of stuff. And if we're talking about devices, I'm looking at this CSR sandbox device and I'm seeing the response time. Ooh, baby, look at those response times. That's how long it takes to connect via SSH. So I'm not pinging those devices. They're actually not pingable, I don't believe. I'm actually trying to establish a connection with them, and then I'm attempting to get a bunch of information from them. That's why the response time is so big. If it was a device that was in my own network, it would probably go way, way, way faster. But as it is, yeah, you can see that response time. Availability, you see that it went away for one polling interval, it seems like. CPU utilization is pretty low, and memory utilization on the device also is pretty low. So there's all this information about devices and about hosts and about services, about workers if you're using workers or looking at that. There's generally a lot of information that gets gathered, and somehow it's getting gathered without your knowledge. What I mean by that is you're not really doing anything to gather it. It just happens in the background, and that is what we're talking about today. So let's look at the code that actually implements this. All right, so here we are looking at the code. I have opened up the init module. This is what we've looked at before during initialization, and I'm going to revisit this as we dive down into it a little bit deeper. But first, look at the structure here under quokka. In my controller package, I have a number of things, but everything that you see here that is called task, those are tasks that are going to be associated with a thread that I create. So compliance monitor, that's for doing compliance monitoring. There will be a thread associated with that. Configuration monitor, that's where I go out and gather configuration from devices and store it regularly. That is happening as well. Device monitor, that's a little bit clearer, and that's the first thing that I implemented. That's going out to devices and finding out if they're still alive. Discover task, that's where I discover hosts. Host monitor task, that is also for hosts, but it is where I am monitoring them. So I'm just going out and pinging them to make sure that they're around. Service monitor, that's where I'm doing various service functionality. Remember, services, I'm not doing pings, but I'm doing HTTP, or I'm doing NTP, or I'm doing DNS requests. That's all the services I've implemented. You could implement more of those. Summaries, this is where we get the summary, that meaning the hourly data that you saw on that graph. That is what happens there. Oh, and I added recently monitoring of workers, mainly of interest for remote workers, to make sure that they are okay. And if we were to go over here and look at the data, would be the summary stuff. This data and information is what is retrieved when I am getting the data. Every time I pull them, I store it in this database, and so that is my host monitor stuff. I have things for devices, so I'm doing device monitoring, etc. And lastly, I wanted to mention, for workers, in case you haven't noticed, I keep track of my workers as well, and for my workers I'm doing things similar to what I do for services and for hosts, which is I'm keeping track of the information related to response time, availability. Oh, and I'm doing this like I'm doing for devices. I'm not keeping summarized data, but I am keeping CPU utilization and memory utilization, because for a worker that's probably something of interest, and it's something that I can provide. So that is an overview of all of these different things. Now let's look a little bit at this actual code in the initialization phase and see what I'm doing. So I want you to pause right now, because I'm going to say some things that if you're not an experienced software developer with object-oriented stuff, it may not make as much sense to you, but it's fairly simple to understand. And so I've given a picture of it before in the walkthrough, so I'm not going to bring that up again, but I want to point out this thing called Thread Manager that I am importing. I'm using it like a static object. What does that mean? That means that I am using this thing as if there's only one instance of it. So when I define Thread Manager and I go down here and look at Thread Manager, I'm assuming that there's only going to be one set of all of this information that you see. When we deal with object-oriented stuff, you will see self dot something, and I'll be utilizing self for all of my methods. But I'm using static methods because this is like a static object as they're defined in other kind of more object-oriented languages like Java or C++ or what have you. And so there's going to be one of these Thread Manager things. And so the way that I reference them is I use the name of the class, and then I call the particular method that is associated with it. And remember, this is one for all of quokka. So there's one instance of that data that we were looking at, and there's one, and it's going to call in here and start device threads. It's going to be dealing with one instance of the data, just so you know that. This is it's like a singleton pattern for those of you that are familiar with that. I'm not enforcing the singletonness. You can do that by creating an object and then forcing there to be only one instance of the object, but I'm doing a kind of a looser implementation of this and treating it as a static class and static object members, etc. So that's what you need to know there. There's just one of these Thread Manager things. I'm not creating a bunch of them. I'm just using the actual class for storing the data and invoking the threads. And so if you look here at the initialization, it's going to be pretty straightforward. I'm starting device threads, and I'm passing in these intervals that I've gotten from the command line. I'm starting the service thread, so there's one of those. So there's 3. Here's 4. Discovery thread is the 5th one. I don't even know why I'm keeping count of these. I'll let you keep count from now on. I'm starting my host monitoring thread, which is this one right here. I am starting the summaries thread. That's the thing that's going out and getting that summary data that we saw, the hourly data. I have a worker thread that's keeping track of the workers. Oh, and here's another one that I didn't talk about, this DB maintenance thread. What is that for? Well, as you can imagine, for things such as this and things such as this, I'm gathering information. And if I don't ever trim away old data, then I will eventually run out of memory on whatever system I'm using, whether I'm using a remote database or a local database or wherever I'm storing it. I might be storing it in files or something. So I want to make sure that I'm trimming stuff away. Now, we could get into arguments about how much data should I keep, how long should I keep it, etc. But for my purposes, my DB maintenance thread goes out, and we can look at that when we dive into it. I don't know if we'll be getting to that today or in this lesson or not, but we can see that I have different time frames that I allow the data to stick around, but that's what that DB maintenance thread is. So I'm going to be calling these things, so let's take a minute and dive down into these and see what they do. Okay, to see how I start these threads, just as an example, because it's the same for each one of these threads, I'm going to choose one of these to dive down into. So just for kicks, I usually do host because it's the simplest and it's not cluttered. I will choose the service thread simply to change it up a little bit. I would choose the device thread, but there's 3 different things going on, and I don't want to get confused with too much stuff on the screen there. So I'm going to dive down into start service thread. So I've done Control B in PyCharm, and it takes me into Thread Manager. So here I am inside Thread Manager, and I have this method called start service thread, and it takes a parameter that is called the interval, the service monitor interval, and this equals means that it has a default value. So if I didn't pass anything in, then I would be setting it to 60, and that's the number of seconds, just so that you know. Now I do 3 things in order to start the thread. This is what I'm going to do. The first thing I'm going to do is I'm going to create an instance of this service monitor task. So service monitor task, remember we looked at all these tasks here. If I was to go here and do Control B to go down into it, this is my service monitor task, and you're going to see that these are going to follow kind of the same pattern. We're not going to look at this in great detail. Here's my constructor, this underscore init. This set terminate is for termination, and monitor is where it's going to spend its life when it actually runs. So that is a quick overview of this task. That's all there is in there. So let's go back to our thread manager. So I'm creating an instance of that task class. So that's going to be my object here. As it turns out, I'm only creating one of these because I only call start service thread once. I don't have a lot of extra stuff to prohibit second ones from getting started, but this only gets called during the initialization phase of my startup of my application. So service monitor task. So now I have this task. The next thing that I'm going to do is I'm going to actually start calling into this threading library. So I'm using Python's threading library. So I've done import threading, or maybe what actually did I do here? Let's just make sure. Yeah, I did import threading for that. Now I have to find my way back to the service thread. Here we go, start service thread. Once again, this is the way that it got formatted by my formatter because the line got too long, but it's just really it's calling in to this class called thread. So it's going to create a class that is of type thread, and is going to create an object of type thread. And this thread I'm passing in, I'm going to have it's going to create it. Sorry for misspeaking there. It's going to create it using this monitor function. We were just there looking at our service monitor task. And if you recall, when we were here, we saw that there is a function inside of it called monitor. That's what I'm pointing it at. All right. Now there's different ways to start threads. My task could have inherited from thread. There's a number of ways to do it. I've chosen to do it in this way, where I'm just passing in this particular method. So I'm passing in this method. So it's when it starts it up, it's going to actually call into this function of mine, this method of mine. All right, so that's what target means. Target tells it, what am I going to be running for this thread? And then what do I want to pass in when I run it? It's going to pass in one thing. It has to have this comma here because it needs to be a tuple. And so I'm going to pass in the service monitor interval. If I look down into my service monitor task, when I look at monitor, then I can see it's getting passed in this thing called interval. And so what happens is, when I call start, when I create the thread is just sitting there. It's waiting to do something, all right? It hasn't actually started yet. It doesn't start until I call start on this thread. This is a method that's part of the base class of thread that I created here, and I'm going to call start. If you're kind of ahead of the game, you'll see, okay, well, this is really calling in to create an object of type thread, and I'm passing in these things as arguments to the constructor, and that is exactly what happens. It happens apart from me entirely. So this stuff is getting, this thread is getting created apart from me, and as part of that thread type of object that it created, there's a function that I have called start, that it has called start, and that's what tells it, okay, begin running that thing, and it's going to use monitor in order to run it. So let's look down at the service monitor task and see exactly what it does. Right, so let's look at what happens in monitor now. Just to review really quickly what I just said, when we created the thread, we pointed it at the function, which is actually a method called monitor, and then we called start. When we called start, it actually will start to run. And what does it do? Well, this is just a function. It's actually a method, just like any other function or method we've called, except there's something, there's not except, but it actually is in this while true loop. So it's going to loop here forever or until we tell it to terminate. So consider this to be something that just runs forever in the background. Now, why am I showing you this particular one? Well, let me show you host monitor task. You notice it has basically the same thing, a monitor with a while true. Device monitor task, it also has a monitor and it has a while true. If I was to go to, let's see, service monitor task, if I was to go to worker monitor task, it has something called monitor. If I was to go to summaries task, it has something called start. Why is that? Well, that's just the name I gave it, the same thing that I gave the name monitor. I could have called this anything that I wanted. Here's my thread manager, and when I come down here and look at my summaries thread, and I tell it what's the name of the thing that I want you to call, I'm telling it to call something called start. This is not related to this start right here, okay? That's just what I called it. I could have called it monitor, but it's not really a monitoring thing. I guess maybe it is, but I just called it start for no other reason. It's effectively the same thing, and I sit in this while true loop. All right, and so that's basically what I'm doing. So let's look at what I do in this service monitor thread. So the service monitor thread is going to be similar, like I said, to the host monitor thread. What I do first, and I do this in all of them, is I get all the services. So every time I go through this loop, I reread all the services. The theory is that somebody could have modified something, and the next time I go through this loop, I'm going to pick up any new ones that were added, or I will remove ones that have been deleted. I don't actually do that. I don't dynamically add and delete services. That does happen for hosts. It doesn't happen for devices, but basically I come through and I read all of the services. So then what I do is I'm going to go through these services one at a time, and I'm going to attempt to get the availability and response time. Now, the one thing that I want to point out here before we go too far is this is going to take me through every one of those services that I've just read from the database. Now it's going to go through all of those, and then what is it going to do? It's going to wait for the interval. Now this tells you something. Don't worry about this code right now. Just trust me when I say this is causing it to wait until this interval has expired. So it starts at 0 and it goes until the interval is totally expired. All right? And what it's going to do is it's just going to sit here, and when the interval is expired, it's going to resume again. What does that mean? Well, when the interval gets passed in, this interval right here, and we can look at it right here, these intervals, that's the summaries. Let me go to, yeah, we could use any of these. The start service thread. This interval that we read in, if the interval is 60, that does not mean that we are going to pull the services every 60 seconds, okay? So pay careful attention to me. This isn't a huge deal operationally, but it's important to understand this. And this is not the way that I would do it in a real product. Typically, if somebody said, if you give an interval and you say like every 3 minutes, my interval is 3 minutes, that means, okay, I'm going to do this every 3 minutes. And the problem with that, it's not really a problem, but it just makes it a little bit more complicated, is the calculation of how long to wait depends on when I started. My time to go round trip through all of my services may take longer than that particular interval that was passed. So I need to make note of that and not start up again until I've done the previous. There's a whole bunch of stuff that I would use to ways that I would improve this. But right now, all I'm doing is I'm saying, okay, when I'm done with all of my services, then I'm going to wait that amount of time. So basically, if my interval was 60 seconds, that basically means my thread here is going to take a break for 60 seconds once it's all the way done. So if going through all of the services took 30 seconds, then I'm getting updates like every 90 seconds or something like that. If they're all available, it goes super fast and it's quick, but just be aware of that. When you read this, don't be surprised and think, uh-oh, this isn't doing what Chuck thought it was doing. It actually is doing what I thought it was doing. It's probably not the best way to do it, but for doing a cheap and cheerful way to get something up and running and to demonstrate it for you guys, that's how I decided to do it, okay? So just so you know that. And then let's look at the guts of this just so that we see what's happening. What am I going to do? I'm going to call this thing called get availability and response time, and this is going to be different for every one of my monitors. Doing it for a host, I'm going to be going and pinging every device. Getting it for devices, I'm going to be going out to that device and I'm going to be attempting to connect to the device and get information for the device. So these are all going to be different. For services, just so you know, let's dive down into it. This is defined within my service monitor task, and here is where I do the specific request to get availability and response time depending on the type of service. So if it's HTTPS or HTTP, then I'm going to use this requests library, which is a Python library for doing HTTP stuff. If it's a DNS, if the type of service is DNS, then I've got this Python package that has something called a DNS resolver, and I'm going to use the resolver in order to get the information. So I do a query here. And if my service type is NTP, then I'm going to use this NTP library where I can create an NTP client and I can do a request of the NTP client. And if you look up here at my imports, you can see that I have, here's my DNS resolver, all the DNS stuff. Here's the NTP stuff that I'm using. and here's my request library that I'm using. So this is telling you how I'm actually doing this. Now, were this to be like a real product, like I created a product that did this very thing and we had 30 or more different services that we would monitor in the network. If that was true, I'd probably want to have more stuff. I would want to pull all of these different availability and response time things out of here and put them somewhere else. But just to be simple, I left them in here for now. If you were going to expand it, that would be one of the places that you would expand it. So anyway, I go and get availability and response time. When I'm done, I set the availability appropriately. Yeah, so if I didn't get the availability correctly, what I'm going to do is I need to update my service with the status, which is going to be that it's not available. And I'm going to record that, and I'm going to set the service object, and then I'm going to log the fact that, hey, I was not able to communicate with that service. And so you'll see some of those in the event log. In fact, let me see if I can look in the event log here. Let's go and see if there's any availability issues. Let's see, AVAIL. Let's see. Oh yeah, here we go. Those are basically what we had. So there are availability failed for all of these. This is for hosts. What I should do is do availability for service. Let me see if I can find that. Okay, here we go. Availability failed for service, and you can see David Bomble's website was down one time. NTP was down a few times. There's only 15 total. Mostly these are NTP, but I did see one from David Bomble's website that it went down periodically. That was what's today? Today is the 2nd, so that was today in the morning. Anyway, you get the idea. That's where I'm setting that information right there. So if not availability, then I don't want to try to do the response time or update last heard. So if I do have availability, then I'm going to go ahead and set the response time appropriately. I'm going to set last heard appropriately, and then I'm going to do this record service status and set service just like I'm doing right here. And that is the anatomy of how we do polling for services. The others are quite similar. So let's look at how these things get shut down. Now I'm using service, but the other threads are implemented with the same pattern. So you can consider this to be true not only for services, but also for hosts and devices, etc. So I have something here called stop services thread, and the question is, where does that get called from? Well, it gets called from here. This is my init function, and this is where all of my initialization stuff ended, and I went back to Flask. But what I did is I defined something called shutdown, this function called shutdown, and I'm actually registering my process, which is the Flask process. I'm registering this function to get called when we are shutting down, and that would be when somebody does Control C. And so when somebody does Control C, we're going to go through and we are going to do this thread manager, initiate, terminate all threads, and then we're going to actually try to stop all of the threads. So let's look at initiate, terminate all threads. And this is what we're going to do. We are going to come in to thread manager here, and if we have a device monitor task and thread, then we're going to set terminate, and we're going to do the same thing for compliance, configuration, host, service, etc. So this is where set terminate is actually going to get called. Oops, this is the part where I realized that I call set terminate twice when shutting down. Not fatal or harmful, but still a little bit embarrassing. Listen on. Okay, so hello, here I am in my service, in my thread manager, And I've noticed that for this particular situation, I'm actually redundantly calling set terminate. Now in my service monitor task, when we call set terminate, if I've already called it before, then I don't set this again and I don't log the message again, but I probably don't have to do that. The reason that it exists in this manner and the reason that it's getting called in this way is that I want to initiate shutdown for everybody at the same time before I actually begin. And so I initiate the termination of all threads. And when I do that, I go through as we looked at, and I'm going to go and I am going to set terminate for all of these different threads that are actually out there running so that I can get them started in the termination process. The reason I do that is because certain situations like polling of devices take a long time to shut down. So when I actually do this initialization of termination, then when I subsequently come down here and say stop service thread, I don't technically need to do this. Now the reason that it's still in there and that I haven't done anything about it at this particular point in time is that I actually do call stop service thread at another point. If you will notice in the quokka user interface, I can come down here and say reset services, and that will actually stop and restart just the services thread. So it's redundant and unnecessary, but it's harmless at this particular point in time. But the thing that's going to happen that's important is this, and this is the line that you need to be aware of. If you want to wait for a thread to complete, in other words, if you want it to shut down, the method that you call is join. I know that that's not intuitively obvious, but that is just how you do it. And so this is where we're waiting for that thread to complete. Now what happens within my task itself? The first thing that happens is when somebody calls set terminate, I'm actually going to set my internal terminate variable, my member variable, to true. And if you recall a couple things, number one, if I'm in this waiting situation, like if my interval was 1 hour, then when I woke up and was going to go for my next iteration through the loop, I would see if I'm going to terminate, and if I was, then I would break out of here. At some point in time, if it gets set, even if I'm not having to wait, then I'm coming through and I will check for every one of the services. Before I do the next service, I will see if I've been requested to terminate, and if I have, then I will break, and this will break me out of this for loop. And then when I am done with that, I'm going to break out of this, and you will see my while loop. I am not only doing while true, but I'm also checking to see if self.terminate is set. And if it is set, then I will log that I'm gracefully exiting monitor service. Now I've gone back and I've started just quokka, so I did a run quokka here, not a run all. So that what I can do is I can hit control. The way that I stop quokka service is I do control C twice. So I'm hitting control C, and the second control C actually gets in there. And here you'll begin to see these things that say gracefully exiting monitor worker, monitor device, monitor configuration. There's monitor service. When I eventually get to the point where I'm shutting it down, you can see I'm shutting down my host. Here I'm shutting down the service monitoring thread. Here I'm shutting down the summaries thread. Device monitoring usually takes a while. Compliance monitoring takes a while. So I'll sit here and wait while this takes place. Okay, here we see that we have successfully shut down all of the threads and we are terminating. You notice it took a while for us to finally complete that. But We eventually did shut down compliance, and everything is looking okay. So that is the shutdown process on the Quokka server. Okay, so to review what we were talking about, we were looking at where all of the data that populates these graphs and these tables, etc., comes from. And the answer is it comes from the background threads that are running within Quokka. And Quokka does a number of things to start the threads. It has this thing called Thread Manager, which starts all of these different threads. When we go inside the Thread Manager, we see that there is code to start the threads. We looked at services, although services is representative of all the other stuff. We did look a little bit in more detail at the service monitor task, and specifically at this monitor function. In addition to shutting down, we saw the monitor function is doing a while true loop, and that it basically goes out and gets the availability and response time and stores those things. And once again, to reiterate, this is representative of what happens for hosts and devices and workers, and even the summary stuff that actually does something entirely different but runs at periodic intervals. And we talked about how our interval is not really an interval. In other words, we don't gather the data at that every 60 seconds or whatever it might be, but that's the amount of time that we rest in between completing, going through the loop of all of the services in this case, or hosts or devices or whatever, and starting up again. So that is what we do, and how we start the threads and how we run the threads and how we terminate them. Hopefully that's been helpful to you in understanding how Quokka works and how the Quokka services run in the background to give us all of this cool data that we get to look at in these graphs and tables, etc. Hopefully that's useful to you in understanding Quokka, and thanks for listening.